So like if I have to plug in 1 for the 5, if I go 2 times 1 plus 3, and I get 5, do the same thing again with 2, and I get 7. 2 times 3, then I'm going to get 9, then I'm going to have 11, then I'm going to have 13, then I'm going to have 15, and then I'm going to have 17, and I just keep plugging the next value in. 2 times 3, 2 times 4, 2 times 5, so on and so forth. So then as far as what makes it arithmetic is that we're continually counting by 2. Okay? If it looks like a linear equation, if it has the form of like mx plus b, where like you have a slope, you have a constant rate of change, then it's going to be arithmetic. Okay? Just like we talked about yesterday. So then as far as the series is concerned, I'm going to take this and I'm going to add everything up. I'm going to have 17 plus 15 plus 13, 11, 9, 7, 9, and 5. So whenever I do this, 20, 50, 70, 77? Hi. Then again, you would do the same thing. So in this case, are we going to start with 1 though whenever we plug it in? On the second one? No, we're going to go with 3 times 3 minus 7, 3 times 4 minus 7, 3 times 5 minus 7, and then 3 times 6 minus 7. So I'm going to end up with 2, I'm going to end up with 5, I'm going to end up with 8, and then 11. Add everything up, I'm going to end up with 26. Okay. Now, do you want to have to figure out what every single value is in the sequence and then add everything up? Probably not. Okay? We really don't want to, 4 of them's not so bad from 3 to 6, but we really probably don't want to write 7. We definitely don't want to write any more. So then what we can do is use a formula to find out how we will find the actual sum of my series. Okay, so what I'm going to do, everything is still the same. It's still going to be, I'm still going to need the first term. I'm still going to need to know the a sub nth term. Whenever you have an arithmetic series, you need to know what the first term is, you need to know what the last term is, and you need to know how many terms in your sequence or series that you have. Okay? So in doing that, to basically shortcut it, you don't have to add everything up. It's not smart just to add everything up because that's going to take more time and effort whenever you can just plug it into the formula. Okay, so what I want to do is first off figure out what the first term is, what the last term is, and then how many terms do I have. Okay, so whenever I do this, usually it's just like we talked about yesterday. There are going to be different cases as far as the amount of information that you are going to have. Okay, so in terms of what you have, we need to know how many terms. We need to know what the first term is, and we need to know what the last term is. How many terms do we have, or how many numbers are we going to add together? What is the number up top? It's 20. Okay? Now, because I always want to check to see how many, did I start at 1? Did I start at 5? Depending on how many values that I actually am working with. Okay? So from there, I'm going to have 20 values because I'm starting at 1, I'm ending at 20, so there are going to be 20 values. I then want to find what is a sub 20 and what is a sub 1. So all I'm going to do for like a sub 1 is I'm going to take my rule that I'm given here, and I'm going to go 3 times 1 plus 7, and I'm going to get my first term of 10. I'm going to do the same thing then for the 20th term, but I'm going to go 3 times 20 plus 7 and get 67. Is everybody good on how I got 67, 10, and 20? Okay. So then, I'm going to go to my formula. S sub n is equal to n times a sub 1 plus a sub n, all divided by 2. So, I'll go with 20 times 10 plus 67 divided by 2, and then really just becomes plugging everything in. You can, like in this case, since you have 20 terms, if you want to get rid of the 2 and you just want to make this, if you want to simplify the 20 and the 2 and turn this into a 10, I have no issue in that. Okay, you're going to get the same answer if you would have taken 20 times 77 divided by 2, you're still going to get the same answer, and you're still going to get 770. Okay, as far as my answer. I'll do the same thing for the second one, where I always have to know, I need to know how many terms I'm dealing with, what the first term is, and what the last term is. How many terms do we have? 15. What's my starting term? So negative 1, or negative 2, excuse me, times 1 plus 4. So a sub 1 is just going to be a positive 2. A sub 15 is going to be negative 2 times 15 plus 4. So negative 26. So take those 3 values, plug it into my formula, and go to work. Whoop. So 15 times 2 plus negative 26 divided by 2. So I'm going to have 15 times negative 24 divided by 2. If you want to call that negative 12, I have no issue in that. So negative 12 times 15. So a sum of negative 180. Like your case 2, so case 1 is you have the formula and you can go. Case 2 is you have the first so many. Case 2 is basically they just give you a list and you go from there. So the first thing you want to do, if they just give you a list and they tell you find the first 40 terms of the arithmetic sequence. Now again, you could write out, you have 5 of them, you could write out the next 35 terms if you would prefer. That's completely up to you. I wouldn't suggest that. That's just me. So what you need to do here is you need to know what your rule is first. So kind of going back to what you did yesterday, if you have like where the last term is. So you want to be able to write the rule. Okay? If you can write the rule without going back to what you did yesterday, that's fine. Okay? Hopefully you would understand if it goes from 5 to 13, 13 to 21, 21 to 29, 29 to 37. What are we doing each time? We're adding 8. So then it's adding 8 each time. Again, do we know what n is? How many terms are we adding together? 40. Do we know what the first term is? It's 5. We need to know what the last term is, okay, or the 40th term is. So in doing that, I'm going to have to find the rule first. So I know that it's going to be 8n, so do you remember what the rule was from yesterday? Or what we needed to do? We know what the common difference is. So if we're going to find the rule, remember the rule is just a sub 1 plus the difference times n minus 1. So the first term was 5 plus 8 times n minus 1. So 5 plus 8n minus 8. So my rule is 8n minus 3. What's going to be the 40th term, or what do I need to do to find the 40th term? 40 times 8 minus 3. So the 40th term is 317. So then if I want to know what the sum of the first 40 terms are, I'm going to take n, which is 40, times first term, 5, plus the last term, 317, divided by 2. Again, it's really up to you as far as what you want to do. If you just want to add 5 plus 317 and get 322 and have 40 times 322 divided by 2. If you want to divide that by 2 and get 161 and then go 40 times 161 and get a grand total of 6,440. Now, on case 3, it says find the sum of the arithmetic sequence. So, in this case, you have the first term, you have the last term, but what don't you know? The what? The number of terms. So, we don't know what n is. We know that the first term is equal to 6. We know that the we know that the last term, or a sub n, is equal to negative 30. But we need to figure out what n is. You can do this a couple different ways. You could fill it in again if that's what you want to do and say, all right, I started at 6, I'm going down by 2. Okay. And go from there. But again, we want to know how many total terms I have. Any ideas as far as what you want to do or how you would go about it? Plug it into what? To which one? The rule. Okay. So if I plug it into the rule formula, and I do that, if I have a sub n equal to a sub 1 plus d times n minus 1, which one do you want to use? Which number would be the smart one to use? Trying to find the total number of terms. You're right in terms of what you want to use. But what value, you're trying to find n, right? what is the nth term of this sequence? Negative 30. Very good. So I'm going to take negative 30 equals 6 plus, what's my common difference? Negative 4 times n minus 1. I'm just solving for n here. So I'm going to distribute the negative 4. So I'm going to have 6 minus 4n plus 4, negative 30. So I'm going to have negative 30. I'm going to subtract the 10 that I have between the 4 and the 6. So I'm going to have negative 40 equals negative 4n. Divide by negative 4. So n is equal to 10. That number can now go here. Now I can complete the sum, okay, of my series. It'll just go straight into my formula of S sub 10, and I'll have 10 times the first term, so 6, plus a negative 30 divided by 2. So I'll have 10 times negative 24 divided by 2. So 10 times negative 12. So the total is going to be a negative 120. Good job. So again, you have the starting value, you have the ending value. You need to use the rule that you were given yesterday. Okay, everything's going to be tied together. Everything with arithmetic, sequence, and series is tied together somehow, some way. You can still use the knowledge that you gained yesterday for the information for today, because it's going to come from the same. It's coming from the same values. Okay, so we used the previous day's formula. We used the series formula here yesterday to figure out how many total terms. Okay, so if you're given the first term, you're given the last term, you're always going to want to use the last term, because that's where you end. So that's going to be your nth term. Okay. Now, last one. Okay, is when you have, it says find the n value. So it gives you your total, it gives you your rule. You don't know what your last value is. You don't know how many total values you have. So what we need to do to find this, okay, is to, anything like this these are gonna be your longest ones. I'll just go ahead and tell you that right now. Okay? That anytime that you have the total and you have the summation and it tells you how many terms do you have in your list, okay, it's going to make it a lot. This is going to be the hardest one that you do. Okay? I'm not going to sugarcoat it. I'm just going to be honest with you. So we need to find what n is. Okay? That's what we're looking for. We do not know what n is. If we're using S sub n equals n times a sub 1 plus a sub n over 2. Okay, that's just the formula we've been using up until this point, right? Do we know what the first term is, or can we figure out the first term? Okay, how are we going to figure out the first term? Just plug it in, right? So I'm going to have negative 4 times 1 minus 1. I don't know why there's an extra parenthesis. Oh, it just had the parenthesis around it. So negative 4 minus 1. So my first term is negative 5. I'll come back to that in just a second. Now, from here, then it becomes, I need to know what the last term is to find my previous term. What's another way of saying a sub n? What was a sub n yesterday? So, whenever we said, hey, what is a sub n? Well, a sub n is, like Madeline said, either the formula or the rule, right? So, whenever you're given this part right here is a sub n. Now, I'm going to write everything in terms of n, so I know it says 4i. We're going to write it as 4n, or negative 4n. Okay? But all I'm going to do is I'm going to take all this information and I'm going to use the formula that I have up here. I don't know what n is. Okay? Still trying to figure that out. Do I know what the sum of everything is, though? What is it? Negative 1127. Okay? So all I'm going to do is I'm going to take negative 1127 equals n times negative 5 minus 4n minus 1 over 2. Now, from here, there's a lot of different ways that you can go about doing this. Okay, one way is just to kind of move the first thing I would definitely do, though, is combine the top. So then, let's write it in a different color. So if I go negative 1127 equal to negative 4n minus 6 all over 2. And I'm going to put the n on the back side. Okay, it just kind of puts everything out here to the side. Now, in this case, you have a couple different options because everything on top is divisible by 2. That's not always going to be the case. Okay, the one thing I want to get rid of, though, I want to get rid of the n, or I really just need to distribute the n to everything inside here. So then whenever I do that, I have negative 1127 equal to negative 4n squared minus 6n all over 2. Again, you can do this really however you want. You can, I would get rid of the 2 somehow, some way. You could divide everything on the right side by 2. Because everything's, or, what do we say it again? Multiply everything by 2, right? Okay, or really multiply this side by 2 and multiply this side by 2. Laura? So because this is really over 1, so since I only multiply the top with the top and the bottom with the bottom, so then whenever I multiply that right side, I'm going to have negative 2,254 on the left side. And I'm going to have negative 4n squared minus 6n. Move everything from here. I would move everything over to the other side. So in doing that, I'm going to have 4n squared minus 6n, plus 6n, minus 2,254 equal to 0. Now from here you have a couple different options depending on I probably wouldn't factor this because you might be here a while. If there was only a formula that you could use, on this case, I would probably make this a lot simpler because everything's even and I would divide everything by 2. Okay. What? Oh, I thought you had a question for me. That's all right. So, whenever, you could divide everything by 2 and have smaller numbers, or you can use quadratic formula. If you remember the quadratic formula, opposite of b, plus or minus, square root. Oh my gosh. Or if you have the graphing calculator and you have the Quad 4 program, it will spit it out for you. So plug it in as far as -6 plus or minus 6 squared minus 4 times 4 times -254. All divided by 2 times 4, which is 8. So then I end up with -6 plus the square root of 36,100 divided by 8. Well, the square root of 36,100 is 190. The only one that I have to do, though, once I get it to this point, I can't have a negative number in my list. Does that make sense? You can only have the positive version. So I only need to worry about -6 plus 190 over 8, or some would call that 184 divided by 8. And that is 23. That's how many terms are in my list. Okay. Anytime that you have ones that look like this case 3, like I told you before we started, they're going to be the longest ones. They're not that they're necessarily difficult, but they are a little long and tedious. But you will have a quadratic, and you will have to use a quadratic formula for problems like this. Okay? Just telling you that before you start.